Hi friends, welcome to private 5G networks design and planning optimization session number 2. I hope you all are happy, healthy and doing well. So these are the topics for this complete training. So in the previous session, we have already covered 5G building blocks for the private networks. Right? So we have already covered the 5G building blocks for the private networks. So in today's session, we'll try to cover the topic number 2, which is mastering the basics of private networks. And as we move on in the next week or so, we'll cover all the rest of the topics as well. So hi friends, this is Gaurav Goyal. First of all, thank you so much for joining this training session. Instead of spending your time on Netflix or social media, you are here to learn something new. So that tells me you are very serious about your career and your personal growth. So I truly appreciate that you have taken the time to be here today. From the bottom of my heart, thank you for giving me your valuable time. And I will do my best to make every minute of this training useful and worthwhile for you. So now let me briefly introduce myself. My name is Gaurav Goyal, and I have been in telecom industry for more than 20 years, mainly in the wireless communication. So I have worked with some of the largest telecom operators in the United States, like AT&T, Verizon, T-Mobile, Sprint, Dish, etc. And I have also worked with leading telecom vendors like Ericsson, Nokia, Samsung, and also with Infovista, the company behind the Planet RF planning tool as a product manager, right? So before moving to United States, I worked on telecom projects for various countries like India, Nigeria, Japan, Finland, UK, etc. So I started my career in 2G era and then worked on 3G, 4G, LTE, and now 5G. So over the last several years, my primary focus has been on 5G, AI, NTN, in-building solutions, all these things, right? And I have IB Wave Level 3 certification as well. So I have good experience with designing all kinds of venues, be it stadiums, airports, all these kinds of venues. And if you like to know more about my background, you can visit my LinkedIn profile. And I have already shared the link of my LinkedIn profile with you. So I hope you are able to open that LinkedIn profile. So if you go to my LinkedIn profile, you can see my all my experience, everything, all my posts on this LinkedIn profile. In addition to that, you can see all the certification I have done, all the recommendations, right? So all these things you can see on my LinkedIn profile as well. So I request everyone to follow me on LinkedIn so that you can see the upcoming webinars, my new posts, my new trainings, all these things can be updated on my LinkedIn profile. Okay. So Ravi, have you received the links? Like I'm talking about these links. Okay. So are you able to open? Okay. Thank you. Thank you. Okay, so as I said many times, the only source of knowledge is experience, meaning that true knowledge or true understanding doesn't come from reading, hearing, or thinking about something. You actually have to do it or live it. So you can't learn cycling just by reading books on cycling. You have to go out, learn the cycling by yourself, right? So so that you can understand how it feels or how it works. So like in every webinar, I would like to begin with a thought that can help us not only in our careers but also in our personal lives. So have you ever wondered why some people keep growing, learning new skills and achieving bigger goals while others remain in the same place for years? So one of the biggest reason is fear. A simple diagram explain our journey from comfort zone to the growth zone. So first of all, you see here one thing called the comfort zone. So this is where we feel safe and in control. So everything is familiar. So we know exactly what to do because we have done it many times before, and there is very little risk, very little stress, and life feels comfortable. But there is one problem here. There is little growth. So if we stay here forever, our knowledge, skills, and career stop progressing. Then comes the fear zone. So the moment we try something new, we enter the fear zone. So this is what most people stop. So we start thinking, what if fail? What if people judge me? What if I'm not good enough? So our confidence drops. So, and we make excuses. We become influenced by other people's opinions. The truth is that fear is the natural path of our growth, and everyone experience fear at some point of their time. The third point is the learning zone. So if we decide not to quit at the fear zone and continue moving forward, we enter the third zone, which is called the learning zone. So this is where real development begins. We start learning new things, looking for opportunity, solving problems, challenging ourselves, right? So this is exactly what happens when someone learns a new technology like AI, 5G, all these kind of things, right? So initially it is uncomfortable, but every small steps increase our confidence. And finally, we reach fourth zone, which is growth zone. So here we have greater confidence, clear goals, a stronger sense of purpose, having a vision. We have start achieving our goals, right? So it happens because we are willing to move through fear and learning zone, right? So if I connect to our telecom industry, many engineers were very comfortable with 2G, 3G, or LTE. But when technology like 5G, Open RAN, AI, NTN, private network appears, many people were afraid to learn them. Some stayed in their comfort zone, and but other invested time in learning, and today these professionals are leading projects, getting better opportunities, and advancing their careers. The technology changed, but more importantly, they have changed, right? So remember, my friends, this simple journey. So comfort zone give us safety, fear zone test our courage, and learning zone builds our skills, but growth zones transform our future. The only way to reach the growth zone is to first pass through our fear zone. So, friends, every expert you admire was once a beginner. The difference is that they keep learning and never stopped learning. So, keep learning, keep challenging yourself, and keep growing. Your future self will you thank you for it. And before we jump into today's topics, I would like to request one small favor from all of you. So, every new technology is challenging at first, whether it is 5G, AI cloud, or any other subject. It requires our complete attention. So, your involvement during the session is the key to getting the maximum benefit from today's webinar. So, if it is not absolute necessity, I kindly request you to close your Outlook, WhatsApp, Facebook, LinkedIn, emails, or any kind of social media or any kind of notification for next hour or so. Why I'm saying so? Because research have proved that multitasking is largely a myth. There is nothing called multitasking. Our brain doesn't do two tasks simultaneously. It simply switches rapidly between two tasks, but it can't do two tasks simultaneously, right? So every switch costs us focus, time, and understanding. So if it is not required, please close all kind of social media. So if you're ready to learn and promise to stay focused, say yes in the chat box, and then we can begin our session. So let's see how many enthusiastic learners we have today. So please write yes in the chat box, and then we can begin. Okay, thank you. Thank you. So, in the previous session, we have covered 5G building blocks for the private networks. Let's recall quickly in next few minutes, and then we can jump to our second topic, which is mastering the basic of the private network. So, in the 5G building blocks, we have seen 5G motivation, 5G key drivers, use cases, 5G performance requirements, and NR frame structure and the numerology, right? So in the 5G motivation, we have discussed why 5G is required, why 4G is not enough. So we started with complete fundamentals. What are the main components of a telecom, which is UE, RAN, and the core network? Then we have discussed what are the main components of RAN. So we have talked about various kinds of antennas. We have talked about radios and BBUs as well. Right? After that, we have discussed how they are connected. Like UE is connected with tower with the air interface, and tower is connected with the core network with various things. It can be connected to satellite, fiber optics, or the microwave. Next, we have discussed the evolution of mobile communication, how mobile communication evolved from 1G to 2G, then to 3G, 4G, and now 5G. And in the maybe in the few years or few months, 6G is also ready to come. And we have seen various different names of different RANs. Like for 2G, it is called GE-RAN. For 3G, it is called UTRAN. For 4G, it is EUTRAN. And for 5G, it is also called NG-RAN. And we have seen the vision of 5G according to NGMN. So we have discussed what is NGN, which is new generation mobile networks, right? It is one of the body which develops 5G. And we have seen some of the use cases of 5G, like broadband access in the dense areas or where there is lots of congestion, real-time communication, IoT, broadband everywhere, and high user mobility. Like in LTE, maximum mobility supported is 350 kilometers per hour, but in case of 5G, it is around 500 kilometers per hour, right? And all these things we have discussed in our previous sessions. After that, we have also seen the fourth industrial revolution, which is now going on and which has all these things like artificial intelligence, quantum computing, robotics. All these things are there in the industrial revolution 4.0. 4.0. So if you see the term 4.0, you should know that we're talking about industrial revolution 4.0. Okay. And we have also seen what are the building blocks for 5G. So here we have seen in 5G, three main use cases were introduced, like EMBB, URLLC, and MMTC, right? All these cases. So all these cases have different kinds of requirements. Like EMBB maybe have higher throughput, URLLC may be requirement of low latency, and MMTC has requirement of high connection density and longer battery life. And we have seen the various, as I said, user scenarios for EMBB, for URLLC, for MMTC. All these things we have covered in the last session. In the end, we have also seen this triangle. So we have seen this triangle many times. So this triangle clearly explains all the three cases and what are the requirements of all these three cases. Like in case of enhanced mobile broadband, peak data rate can be 10 Gbps for uplink and 20 Gbps for downlink, right? And for ultra reliable low latency, latency should be less than 1 millisecond. All these things we have discussed. And we have some quizzes also last time. So we have already covered the last time, but just to recall, can you answer this question? Um, what are the three uses scenario for IMT 2020? Can anyone answer this question in the chat box? Okay, thanks for giving the right answer. So as you know, the right answer is C, right? And we have also discussed massive machine type communication, and that is related to billions of sensors and machines. And this is a triangle we have discussed, right? And after that, we have discussed the performance requirements of 5G. So we have gone through what are the requirements of 4G and what are the similarities and differences in 4G and 5G. So all these things we have discussed, like in 4G, maximum channel, maximum channel can be 20 megahertz, but in case of LTE, maximum channel can be 20, but in case of 5G, it can go up to 400 megahertz as well, right? And we have seen the eight major capabilities of 5G. So like here, our user experience data rate should be 100 Mbps, latency should be 1 millisecond, all these things we have seen. These are the eight currencies we have discussed. All these things like reliability, connection density, how much should be there, mobility, latency, all these things we have covered. Again, if you don't remember the 5G performance requirements, so these are the requirements for 5G. So peak data rate should be 20 Gbps for downlink, uh, more than 1 million devices per square kilometer, and cell edge data rate should be 100 Mbps for downlink and 50 Mbps for uplink. Obviously, it depends on the area. Like for rural area, it may be different. For hotspot area, it may be different. But in general, it should be 100 Mbps and 50 Mbps for uplink. So all these things we have discussed in our previous session. And in addition to that, we have discussed the numerology of 5G as well. So if you ask me one major feature that is introduced in the 5G, that is flexible numerology, right? So in case of LTE, we know that subcarrier spacing is 15 kilohertz, but here in case of 5G, it can be flexible. It can be 15, 30, 60, 120, 240. So these are the options that are available because in 5G, there are many different cases. Like we already said, like EMBB, URLLC, and MMTC. So for each cases, we have different requirements of sub-carrier spacing. We have discussed how OFDMA works, what is the cyclic prefix, and how that can be used. Sorry, I have clicked somewhere. Just 1 second. It's not working. Something happened. Just yeah, sorry. Yeah, now it's working. Yeah. Then we have discussed cyclic prefix as well, right? And how it works. This also we have discussed. So OFDMA discussed. As I said, various kinds of numerology, like numerology 0, which has subcarrier spacing of 15, 130, 260, 3, 120, and 4, 240. So we have discussed all these things in our previous session, which is very much required for 5G private networks. I hope you have seen the recording of the previous session. So if you don't, so it is on my YouTube channel. So you can see the recording of previous session. So let's jump to our today's topic, which is mastering the basics of private network. I hope you have seen the recording of previous session. Can you write yes in the chat box if you have seen the recording of the previous session? So I have shared the YouTube link with you. So I think you must have those links, right? Okay. Thank you. Thank you. I think most of the people have seen the recording. Thanks a lot. So let's jump to the topic, which is the mastering the basics of private networks. So in this session, we'll cover. So in this session, we'll try to cover these few topics. So first is describe the concepts and characteristics of private network. So we'll begin by understanding what a private network is and why organizations are increasingly deploying their own dedicated wireless infrastructure. So we'll also explore the key characteristics that make private networks secure, reliable, and highly customizable, right? Next, we'll compare private cellular, public cellular, and Wi-Fi and understand their differences. Because when we understand their differences, it will help us choose the right technology based on coverage, performance, business requirement, etc. After that, we have CBRS. So CBRS introduces several new terms that can seem confusing at first. So in this section, we'll simplify the most important CBRS terminology so you can understand how the ecosystem works. And then we'll go to the CBSD. What is CBSD? CBSD is Citizen Broadband Service Devices. So not all CBSD are same. So we'll look at different CBSD according to our needs, according to their capabilities. And finally, we will compare private LTE, private 5G, Wi-Fi, and IoT technologies and see which one is the best fit for the different enterprise and the industrial use cases. So what is private networking? So private networking is exactly what the name suggests. So it is wireless network that is built exclusively for single organization rather than being a shared with millions of public users. So think about mobile network you use every day. So whether you are using AT&T, Verizon, T-Mobile, everyone shares the same public infrastructure. So during those busy hours, speed may drops because thousands of users are connected to the same network. But a private network is different. So in private network, instead of relying on public operators network, an enterprise or a company or an organization deploy its own dedicated wireless infrastructure using 4G, 5G, or even Wi-Fi technology as well. So this gives the organization complete control over its network. So now the question comes, why do organizations need a private network? Because many organizations can't afford network congestion, because the public network can be affected by congestion if lots of people come, right? Or it can be down. But in organization where networking or signal is very important, this can't be accepted, because suppose a manufacturing plants which has robot which is controlling the robotic machines, right? So here congestion will not be accepted. Maybe at airport baggage system, maybe in hospital where medical devices are connected, mining with autonomous vehicles, warehouse which are handling thousands of scanners, right? So in these things, if even 1 second of downtime is not acceptable, that's why these environments require high reliability, low latency, and strong security and high performance. That's why private network is required, because a public network can't always guarantee these requirements, right? So private network offers several advantages, like first is high device density. So it can support thousands of connected devices simultaneously without significant performance of degradation, right? For example, imagine a small factory with thousands of sensors, cameras, robots, AGVs. So what is AGV? This term you may have heard many times. So AGV is automated guided vehicle. So this term you will use and you will see a lot in near future. So private network is designed to handle all these devices, scanners, cameras, robots, AGV in a very efficient manner. Then we have this latency. So we know very well latency refers to the time it takes from data travel from one device to other. So applications like automation, industrial automations, remote control, robotics, right? So these require responses within just few milliseconds, right? Few milliseconds. So because the network is dedicated, latency remains stable and predictable in case of private network. That may not be possible in case of public network. Then we have high performance and complete control. So with the help of private network, an organization or enterprise have complete control over network coverage, capacity, quality of service, any kind of upgrades, latency, all these things a network can control. And this kind of control is not possible with the help of traditional public cellular networks. The fourth one is secure communication, or you can say better security. Since the network belongs to an organization, the data remain inside the enterprise instead of traveling across a public mobile network. So this greatly improves our privacy and reduces cyber security risk. Remember the term, it reduces cyber security risk. There is a nothing called 100% risk free, right? But it definitely reduces a large amount of cyber security risk. So let's take the example of one manufacturing plant. Suppose a factory has 500 robots. Suppose it has 2000 IoT sensors, hundreds of AGVs, thousands of cameras. So if all these devices depended on the public network, congestion could affect the production. Instead, a factory install a private 5G network. So this will ensure a dedicated beam width, bandwidth, ultra low latency, communication, and reliable connectivity throughout the facility every second of the day. In short, a private network is a dedicated wireless network built for a specific organization using 4G, 5G, or Wi-Fi technologies, right? And this will enable industry 4.0, which has smart manufacturing, enterprise automation, all these kinds of things, right? So this is all about introduction of private networking. Now the question comes, how it all started. So before we talk about today's private 5G or 4G networks, let's understand where the concept of private communication network actually began. It started many years ago. I don't have data which year, but if you heard the term PBX, private branch exchange, right? You must have heard this term in the past. PBX, private branch exchange. So PBX is basically private telephone network installed inside an organization. So instead of every employee having a direct connection to the public telephone network, everyone connects to a central PBX system. So think of it as the company's own internal telephone switch. So what did a PBX do? The PBX had two main functions. First, it allowed employees to communicate with each other internally. For example, if someone in HR wanted a call to someone in finance, right? So the call stayed completely inside the company's own network. It never went to the public telephone network. Second, if needed, PBX could also connect calls to the outside world to the public telephone network. So the question is, in the past, where is the PBX used? So PBX was widely used in like corporate offices. It can be used in hospitals. It can be used in hotels, banks, all these things, or all these places we have used PBX, government places, all these things, right? So almost every medium or large organization in the past have their own private telephone networks. So how did it work? So PBX was actually installed as a central box or cabinet. So this is a cabinet, right? So every desk phone was connected to this box using dedicated telephone cables. So if this is phone, so there may be some cable which is connected to this cabinet. So when someone made a call, the PBX acts like a switch. It determined where the call should go and connected the caller to the correct extension. The important thing here is to remember is that not every call is needed to leave the organization, right? So if I'm making call from suppose reception in a hotel, uh, reception to maybe laundry room, right? So call will remain in the hotel. It will not leave the hotel, right? So this is also one kind of a private network. So most communication happened entirely inside the private network. Only when someone needed to call to the external number, the PBS connect to the public telephone network. So the idea of a private network is actually not new. So organizations have been building private communication for decades. The only difference is the earlier we have cables, now we are wireless. Right? So private 5G is the modern wireless evolution of the traditional PBX concept. So we have seen how organization used PBX system for the private wired connection. So next question is, how did we move from wired private networks to the wireless private networks? Many people think that private LTE and private 5G are something new. Actually, they are not. The concept of private wireless networks has existed for several decades. Different types of private wireless networks existed in the past as well. So over the years, different industries developed their own wireless communication systems for their operational needs. For example, we have Tetra, we have Public 25 for P25, then we have GSMR, which is R means railway. Then we have LTER, R means again it is railways. So each of these were built for a specific industry or an organizations, not for general public. So what does private mean? So private network is a network that is owned, controlled, and operated by a specific organization. It is not available to the general public. So here we see few examples. So GSM stands for Global System for Mobile Communication, and R is for railways. So it is designed specifically for railways operations. Only railway employees, drivers, signal systems, and railway applications are allowed to use this network. Same thing with the LTER, which is the LTE railways, and it may be the advanced version of GSM-R. And another example is Tetra, which has been widely used by police, fire departments, ambulance, airports, all these things. You can say public safety networks, right? And similarly, we have public 25 or P25 that is used for public safety in the North America for the emergency responders, right? Mostly it is used in the North America only, right? So these systems provide highly reliable communication like group calling, emergency calls, push to talks, right? So again, the important thing to understand this is that not all wireless technologies were created for the public. Some technologies like Tetra and P25 were designed specifically for private and mission critical communication. So other like GSMR and LTR can be can be seen as updated version of GSM or updated version of LTE, but they support private enterprise deployments. So today, private LTE and private 5G continue the same evolution. So instead of using older technologies like Tetra, GSMR, organizations are now using LTE or 5G for their dedicated network. So that gives them higher data rates, lower latency, security, high performance, automation, etc. These kind of things, right? So private LTE and private 5G are not completely new concept. Okay, just forget that private LTE or 5G is a new concept. So they are the next generation of private wireless networks built using modern cellular technology. So why so much hype for private networks in 5G? So now the obvious question is, why is everyone suddenly talking about private 5G, right? So why wasn't there so much discussion during 2G, 3G, or even 4G era? The answer lies in the capabilities that 5G brings. 5G is not just another G like 4G, 3G, or 2G. Many people think that 5G simpler means higher speed. No, 5G has many other use cases introduced, which is eMBB, URLLC, and MMTC as well. So the first capability is eMBB. So here we're talking about multi-gigabits speed, something up to 20 Gbps, and it can be used for 4K, 8K videos, virtual reality, augmented reality, all these comes. So it is all about high bandwidth. Then second capability is MMTC, massive machine type communication. So here the goal is to support large number of connected devices. It can be for smart factories, cities, sensors, smart meters. So all these devices can be connected simultaneously. The third capability is low latency communication or URLLC. So here the priority is extremely fast response times, and we are talking about latency as low as 1 millisecond, right? And these can be used for industrial automations, remote surgeries, driverless cars, right? All these things can be used for URLLC. So the question is comes, when 5G is so much capable, why can't public network do everything? So now imagine trying to provide all three of these capabilities on one nationwide public network. Some users need extremely high speed. Some users need ultra low latency, but other needs support for thousands of IoT devices. So meeting all these different requirements simultaneously across an entire country is extremely challenging. So where private network fit in? This is exactly where private 5G becomes valuable. So instead of building one network for everyone, organization can build their network for their own requirements. They can build their own networks according to their needs. So, for example, a factory may need ultra low latency for robotic automation. A hospital may need highly secure or reliable communication. A railway may need mission critical operations, right? So, every company or every organization may have different needs. That's why private networking is very valuable and it can be helpful. And other very good example of this is like limited geography. So for example, it can be one factory, one airport, one hospital, one mining site. So these networks usually covers only a limited area because the coverage area is limited. the network can be optimized specifically for that environment. So 5G is not simply another generation of mobile technology. It is a platform that enables entirely new enterprise applications. And many of these applications simply can't be supported by public mobile networks alone. That's why private 5G is becoming one of the biggest growth area in the wireless communication. And one more thing I want to add here, in 5G standards, you will often hear a different term for private 5G. You may have heard, according to 3GPP, 5G is called NPN, which is non-public network. Right? So if somebody asks you what is NPN, NPN is the another name for private networks. So let's explore different deployment methods for the private network. So the first deployment you can see is in this standalone private networks, mobile network operator builds and manages the private network for the enterprise. So think of operators like AT&T, Verizon, T-Mobile, Vodafone, or Telefonica. So instead of enterprise building everything on its own, it simply asks the operator to deploy a dedicated private network. So let's understand with the help of this diagram. So inside the enterprise campus, we install a dedicated base station. Suppose AT&T install a dedicated base station, which can be E node B for LTE or a G node B for 5G. Employees, phones, tablets, robots, sensors, cameras can be connected to this G node B wirelessly. Right? So question now, who owns and manages this network? So in this model, mobile network operator is responsible for all the things. He is responsible for installing the radio equipment, deploying the EPC core, operating the networks, all the upgrades, troubleshooting faults. So the enterprise get all the benefits of private network without having to build a telecom expertise internally. So in this case, although the operator manages a network, the resources are dedicated to that enterprise. That means only authorized users, which has that particular SIM, which is belong to that company, only authorized users can connect to that SIM. And traffic remains separate from the public subscribers. And the network can be optimized specifically for the organization applications. Right? And what are the advantages? So it can be that it can make the deployment faster, simpler, and less expensive. And it can be used in various places like factories, warehouses, hospitals, campuses, ports, mines, and other enterprises environment as well. And today, many leading operators offer these solutions like Nokia, Ericsson, Samsung, Cisco, Mavenir, all these provides these kinds of capability. So this deployment model, the enterprise gets a full dedicated private LTE or private 5G network, but it doesn't need to become a telecom operator. The mobile network operators builds, manages, and support the network, while the enterprise simply uses it and securely for its employees, machines, and all kinds of cameras, sensors, etc. So in the next deployment model, we'll see a completely opposite approach where the enterprise itself owns and operates the entire private networks without relying on MNO, mobile network operator. Let's jump to the next slide. Friends, can you write yes in the chat box if you're able to understand what we have discussed till now? Okay, thank you. Many people are understanding. Yeah. Can you everybody write yes in the chat box if you're able to understand? Thank you. Thank you. Okay. So next topic is RAN sharing. So far, we have seen a dedicated private networks where the enterprise has its own radio networks and its own core network. While this provides maximum security and control, it can be very expensive. Okay, thank you. Thank you. So so the biggest investment in mobile network is usually RAN, radio access network, right? So this is the one of the biggest investment. right? Because it includes base stations, antennas, power, fiber connectivity, installations, and the ongoing maintenance. So what if enterprise wants to reduce this cost? So that is where RAN sharing comes into picture. So what is RAN sharing? So in this deployment model, the radio infrastructure is shared between the enterprise and the mobile network operator. So however, core network is separate. So core network is different for the enterprise and core network is different for the public users. So think of like this. So the enterprise and the MNO use the same base station or G node B. But once the traffic reaches a network, it is directed to the different core networks. So if it is traffic is for the enterprise, then it will go to this core network. If the traffic is for public users, then it will go to this core network. Okay, so again, in this diagram, users inside the enterprises connect to this shared node. The radio equipment is shared between the two networks. So once connection goes to the enterprise, it will go to the core network. So although the radio equipment is shared, the backend process happens in a different core network. So how does it work? So when an enterprise employee connects using an enterprise SIM, the traffic is routed to the enterprise core. And if a normal public subscribers connect using the same radio, the traffic is routed to the operator's core network. From the user perspective, everything happens automatically. He will not know that where his traffic is going. Is it private core network or the public core network? So what are the advantages? First advantage, as you know, is the cost. We can save lots of cost because RAN is usually very expensive, and it is help in better utilization of radio equipment and having faster deployment because RAN is already there and it can be shared between public and private. So the enterprise saves money without sacrificing control over its own services. So let's understand with one example. So imagine an airport. So instead of installing two separate set of base station, one for the airport private network and another for public mobile users, the same radio equipment can serve both. So airport employees, security staff, baggage system, IoT devices, all these things can be connected to the enterprise core while passengers use the public operators core. So this significantly reduce departmental cost while still keeping enterprise traffic isolated. So RAN sharing is a cost-effective deployment model. It allows the enterprise and the mobile operators to share the most expensive part of the network, that is RAN, radio access network. And we know it consists of various things like G node B, E node B, radios, antennas, power, fiber, all these things are there. Let's see another kind of deployment, which is network slice as a service. So this is the final deployment model and probably the most important one in 5G because it introduces network slicing, one of the key innovations of 5G. So far we have looked at deployment models where enterprises own some physical infrastructure, such as dedicated core network, dedicated radio network. But 5G introduced a completely new concept called network slicing. So this allows enterprises to get the benefits of a private network without deploying any dedicated physical infrastructure. So what is network slicing? Imagine a mobile network operator has one large physical 5G network. So instead of building separate physical networks for every customer, the operator can divide single physical network into multiple virtual or logical networks, right? So suppose we have one physical network like this, but it can be divided into various virtual networks. So it network one, network two, network three, network four, network five, right? Any kind of networks, but these are just logical networks. So these logical networks are called network slices. So think of it like this, like in suppose we have one modern apartment building. Everyone shares the same building, electricity, and elevators, and the water supply. But every family has its own apartment with its own privacy, right? So in network slicing, everyone shares the same physical fiber structure, but each enterprise gets its own dedicated logical network. Suppose enterprise 1 will get network 1, enterprise 2 will get network 2, and so on. So here you can see the enterprise users connect to the operators 5G or radio network, and traffic then enters the operator's 5G network. So instead of mixing with everyone else's traffic, it is placed into a dedicated network slice. And the slice has everything of its own, like bandwidth, quality service, security policies, network function. All these are dedicated only to this particular enterprise. But just to remember, my friends, a network slice is much more than just bandwidth. It can include dedicated logical resources like RAN, transport, and the core network as well. Right? So, why it is called service? Because there is no need to purchase or maintain dedicated infrastructure. Right? Suppose we can understand this one with one example. Suppose a stadium is hosting a major sporting event. For just a weekend, the operator can create a dedicated network slice for security personnel, CCTV cameras, emergency services, and media broadcasting. After the event ends, that slice can be simply be removed. Similarly, a hospital can request an ultra low latency slice for remote surgery, while a factory can request another slice for IoT sensors, industrial automation. So that's why it is called network slice as a service. So it can be ordered or it can be removed anytime. Right? So let's summarize what we have learned so far. So first, private networks are not new. They have existed since the days of PBX systems and later evolved in, into the wireless technologies like Tetra, P25, GSMR, all these things, right? Second, 5G has made private networks much more important because it supports demanding enterprise application that requires like gigabit data rates, ultra low latency, and massive IoT connectivity. And many of these requirements can't be efficiently supported by single public network. That is why enterprises are increasingly adopted private 5G N or NPN as NPN in terms of 3GP, right? So now that we have understand the different deployment methods, we can go deeper into 5G NPN and the base of which is CBRS, right? And we have seen the difference between all the kind of networks. Before jumping to CBRS, let's see what are the main characteristics of private network. So the first characteristic is that it uses small cells. So if you have seen Wi-Fi access points mounted on the ceiling of an office, the deployment of a private cellular network looks quite similar. So instead of Wi-Fi access points, we'll install LTE or 5G small cells throughout the building. So these small cells provide cellular coverage and connect back to the enterprise core network. The difference is that while Wi-Fi uses, if you remember, in case of Wi-Fi, we use IEEE 802.11 technology. But in case of private 5G, we use 3GPP LTE or 5G technology. But as compared to Wi-Fi, 5G will offer better mobility, stronger security, and improved quality of service. The second characteristics is that the network is dedicated. Only authorized users and devices can connect. So unlike a public mobile network where resources are shared among thousands of users, all the network capacity is reserved for the organization. So this provides several advantages which we have discussed earlier, like better security, better performance, consistent user experience, all these kinds of things, right? The third characteristic is that it is the miniature versions of the public mobile network. So it contains almost all the same components like RAN, core, SIM, mobility management, quality of service, security function. The only difference is the scale. So instead of covering an entire city, it might cover a single factory, hospital, university campus, warehouse, airport terminal, and so on. The final characteristic is that deploying a private cellular network requires more planning and investment than simply using an existing public network. The organization needs to install small cells. It has to subscribe to a private LTE 5G core, configure spectrum, manage SIM cards, monitor and maintain the network. Right? So yes, it requires additional cost, efforts, RF design. But why do companies still build private networks if it is so expensive? So answer leaves it the efficiency. The answer is very simple, which is efficiency, because it provides something public network operators can't guarantee, because it provides the organization complete control over the network, strong security, lower predictable latency, better indoor coverage, guaranteed quality of service, high reliability of mission critical application. So, for industries where downtime can cost millions of dollars, the investment is well worth it. Suppose, let's understand with one example. Suppose there is a large automotive manufacturing plant, hundreds of robots, AGVs, thousands of cameras, sensors, are operating simultaneously. If these devices depend on a congested public network, production could be interrupted. So, with a private 5G network, the factory gets dedicated wireless resource, secure communication, and consistent low latency performance. So, this will ensure smooth operations 24 hours a day. To summarize, a cellular private network is essentially a dedicated mini LTE or 5G network built exclusively for one organization needs. Right? And we have discussed various benefits of private networks like guaranteed and control coverage, improved security, ensured capacity and reliability, scalability, predictable latency, high data speed for communication. So these advantages make private LTE or 5G the preferred choice for organizations running mission critical applications where performance, security, and reliability are essential part of the organization. And even 1 second of downtime can cost millions or you can say billions of dollars to a company. So private networks is a cheaper option for these big companies. Yes, in the beginning, it may cost little bit, but in the long run, it will improve lots of efficiency and provides or decrease lots of downtime. Let's jump to the next topic, which is CBRS. So what is CBRS? So CBRS is basically one of the key technologies that has accelerated the adoption of private LTE and private 5G networks in the United States, which is CBRS, Citizen Broadband Radio Service. So it is shared spectrum introduced by the FCC to make wireless spectrum available not only to the traditional mobile operators but also to the enterprises, schools, hospitals, factories, utilities, and many other kind of private organizations. Before CBRS, if an organization wanted to deploy a private cellular network, they have to obtain a license. And you know that obtaining a license spectrum is such a difficult task. But CBRS changed that by allowing organization to use shared spectrum in the 3.5 gigahertz range. The first thing to know about CBRS is that it operates between 3.5 gigahertz to 3.7 gigahertz frequency band. But instead of permanently assigning the spectrum to a single operator, the FCC introduced a shared spectrum model. So this allows multiple users to share the space spectrum efficiently with minimum interference. But you must be thinking, if multiple organizations use the same spectrum, how do you avoid interference? The answer lies in SAS, which is Spectrum Access System. So think of SAS like a traffic controller. So when the CBRS base station wants to transmit, it first connects the SAS. The SAS checks which frequencies are available at that location and assign a suitable channel. But if the condition changes, the SAS can automatically move the device to the another frequency. And this dynamic coordination allows many users to safely share the same spectrum. So in case of SAS, three spectrum a three-tier spectrum model is allowed, which is divided into three tiers. One is incumbent, then we have private access license, and then we have GAA. So we'll discuss in detail about all these in next few slides. Incumbent, PAL, and the GAA. So CBRS supports both LTE and 5G private networks. So you may know that many organizations initially deploy private LTE because of device availability. So today, many are migrating to private 5G while continue to use the same CBRS spectrum. So let's take the example of manufacturing company. So the company wants to deploy a private 5G network across its factory, but they don't have a licensed spectrum. So instead of purchasing expensive nationwide spectrum licenses, it installs CBRS radios. And these radios communicates with SAS, Spectrum Access System, and it receives available frequencies at that time according to the conditions incumbent, PAL, and GA, which we'll discuss in next few slides. To summarize, CBRS FCC manage shared spectrum framework operating in which frequency 3.5 and 3.7 gigahertz. It enables enterprise to deploy affordable private LTE as well as 5G private network. And spectrum usage is coordinated by SAS, Spectrum Access System. The access is managed through a three-tier priority model, which consists of three parts: incumbent, private access license, and the GAA. So now that we understand what CBRS is, let's see who actually uses it and how different industries benefit from it. So CBRS is not just for private enterprise. It is widely used by wireless carriers, mobile operators, internet service providers, and the business to expand wireless connectivity in a cost-effective way. So let's look at the each case. The first one is wireless carriers. So the first use case is wireless carriers that can be Verizon, AT&T, T-Mobile, and these operators use CBRS to increase network capacity, especially in dense urban areas where thousands of users are connected simultaneously. For example, imagine a busy stadium, airport, shopping mall, or any business downtown area, right? So instead of purchasing additional license spectrum, carriers can deploy CBRS small cells to add capacity and improve the user experience. So in simple terms, CBRS helps handle more traffic and reduce network congestion. The second group is cable operators such as Comcast, Charter, all these kind of things, right? So many cable companies operate as MVNO, mobile virtual network operators. And MVNO provides mobile services, but doesn't own a nationwide cellular network. Instead, it purchases network capacity from the major wireless carriers. So by deploying CBRS in location like residential neighborhoods, office buildings, public hotspots, cable operators can keep local traffic on their own infrastructure. This reduces the amount of traffic sent over the wholesale carrier network and helps lower operating costs. Then we have fixed wireless access, right? A CBRS can be used for fixed wireless access, especially in the rural or underserved areas where installing fiber may not be economically feasible. So a CBRS radio installed on a nearby tower communications can help with the fixed wireless access. Then we have enterprise private network, right? So factories, hospitals, airports, all can use CBRS for their private dedicated network and for dedicated coverage. Why CBRS is so popular? Again, the reason CBRS has become so popular is that it offers many of the benefits of licensed cellular spectrum. without the enormous cost of purchasing nationwide licenses. It provides enterprise with an affordable way to deploy secure and reliable LTE or 5G networks, right? So CBS benefits multiple industries. It can be wireless carriers, cable operators, FWA services, and enterprises as well. So here is the history of CBRS. So in 2010, idea came, and then in 2012, FCC identifies the band. In 2016, CBRS Alliance was established, and in 2020, commercial deployment begins. In same year, in July 2020, the FCC held auction 105 for PAL, and today it operates in 3.55 to 3.70 gigahertz, just above the 3.5 gigahertz license spectrum, right? So why this timeline important? So it shows how regulators recognize the radio spectrum is, is a limited resource and introduce a new sharing model to use it more efficiently. So instead of leaving spectrum underutilized, CBRS allowed multiple users to share it dynamically while protecting higher priority users. So in short, CBRS evolved from a spectrum sharing concept in 2010 into a commercially deployed technology by 2020. And today it becomes one of the key enablers for private LTE and 5G networks. So we have already introduced these three terms: incumbent, priority access license, and GA. So let's go in deep for these terms. As we discussed earlier, unlike traditional license spectrum, where one operator has exclusive access, CBRS allows multiple users to share the same spectrum in an organized or a controlled manner. So this is made possible with the help of SAS, right? We have discussed SAS, Spectrum Access System. So let's understand each tier. So first one is incumbent users. So at the top, you can see that incumbent users. So these users have highest priority and always protected. So this can be used for, it can be used for US Navy. It can be used for satellite system, right? The second tier consists of PALs. So these organizations purchase spectrum license through the FCC auctions. So it can be used for MNOs, utilities, large enterprises, etc. So PAL uses receive protected access whenever incumbents are not using the spectrum. So, however, if an incumbent appears, even PAL users must move to the another available channel. The tier 3 is the GAA, which is General Authorized Access. So this is the most widely used tier, and it can be used for factories, warehouses, schools, hospitals, right? So how does it work? It works with the help of SAS, Spectrum Access System. So imagine SAS as an intelligent air traffic controller. So every CBRS radio first asks the SAS, which channel can I use? The SAS checks, is an incumbent using the spectrum? Is a channel reserved for a PAL user? Which frequencies are currently available? So based on this information, it assigns the best channel. And if conditions change, for example, if a Navy radar becomes active, the SAS automatically instructs lower priority to the switch to another frequency. So PAL or GA can be switched to another frequency. All of this happens automatically, right? So we have introduced three terms: incumbents, PAL, and GA. Again, the first one is incumbent. So these users were already using the 3.5 gigahertz spectrum long before CBRS was introduced for commercial use. Because they were the original users, the FCC gave them the highest level of protection. This means whenever an incumbent needs the spectrum, everyone else, like PAL and GIA, must immediately stop using that frequency and move to the another available channel. And who are the incumbent users? It can be federal, it can be non-federal, that can be satellite ground stations that receive signals from satellites. And some of these stations were already operating before CBS was introduced. So they are grandfathers into the system and continue to receive protection. Then we have PAL. So PAL users sit between incumbent users and the GAA, General Authorized Access users. So they have higher priority than GA, but they must still give ways whenever an incumbent users requires the spectrum. So think of PAL as a reserved spectrum access. So unlike GA, spectrum is not free and it has priority over GA users. So one of the biggest advantages of a PAL is priority access. So if both a PAL user and GAA user want to use the frequency, the PAL user get more priority. The GAA user must switch to the another available channel. But remember always that incumbent user always have the highest priority. Then we have this 10 megahertz license channel. So each PAL license provide access to one 10 megahertz channel, right? And if company needs more bandwidth, it can acquire more PAL license as well. And maximum of 7 PALs. So since each PAL is 10 megahertz, an organization can have access to 70 megahertz of license CBRS spectrum, right? So you can say that PAL users are tier 2 users in the CBRS ecosystem. It has more priority than GA, but less priority than incumbent. The last one is GAA. So GAA is what makes CBRS so attractive for private LTE and private 5G deployments. So unlike PAL, GAA do not need to purchase a spectrum license, right? So the first point is GAA users are licensed by rule. So this means organizations do not need to participate in an FCC auction or buy an expensive license. Then we have user availability spectrum. So the spectrum access system continuously monitors and it automatically assigns the available channels to the GA. Then we have available capacity. So in most locations, if there is no incumbent activity, GA users have access to at least 8 10 megahertz channels, right? It provides plenty of bandwidth for many enterprise applications, right? And then GA operates on channels not used by incumbents or PAL users and must accept interference from incumbent and the PAL users. In short, you can say that GA users are tier 3 users in the CBRS ecosystem. They do not need to purchase a spectrum license. They can use any available CBRS spectrum not occupied by the incumbent or the PAL users. Right? And the SAS or the SAS spectrum access system dynamically assigns channels, making GAA an affordable and flexible option for deploying private LTE and private 5G network. So this is all about CBRS. So let's recall what we had learned in this particular session. So first of all, we have learned about 5G building blocks, different kinds of building blocks like 5G motivation, key drivers, performance requirements, spectrum, technology components, building blocks, architect and deployment options, network slicing, and MEC. And we have seen that 5G is not just 4G plus 1. And we have seen the requirements according to NGMN, right? All these things we have discussed. And we have discussed the 8 cases which are introduced by 5G. And all these scenarios we have discussed. Next, we have seen the timeline, how 5G developed from 1G, then 2G, then 3G, and 4G and 5G. After that, we have seen that it is consumer centric, business centric, right? So 1G is about voice, 4G about video, but 5G is about everything, every business use. After that, we have seen the roadmap as well. In addition to that, we have seen the performance targets. So if all these targets can achieve, then only we can call that system as a 5G system, right? After that, we have seen what are the private networks, what are the different deployments, what kind of different deployments can we do in private networks. We have discussed about SaaS, dedicated private networks, shared private networks, all these things we have discussed. After that, we have discussed the deployment options. It can be on premises, it can be cloud based, it can be the hybrid deployment, which is the mix of both on premises and cloud based. And we have discussed why Wi-Fi is not enough, why 5G is required in addition to Wi-Fi, or why 5G is now more important than Wi-Fi. So we have seen that in 5G we have introduced various new technologies like millimeter wave, massive MIMO, beamforming, which gives a lots of big edge to 5G as compared to LTE or Wi-Fi. That's why 5G private network is very popular. After that, we have seen various advantages of private networks, also the benefits of private networks we have seen, and we have compared what is public 5G network and what is private 5G network. After that, we have seen CBRS in details and what are the three tiers of CBRS band users. And we have compared 5G overview and the private network as well. So this is the summary. So friends, as I say in every class, that to grow, you need four things: passion, skills, experience, and target. With the help of these YouTube videos or these kind of seminars, you can improve your skills. So keep training, keep learning until you get it right. Again, friends, this is me. My name is Gaurav Goyal. I request everyone, please follow me on LinkedIn and please subscribe to my YouTube channel for the upcoming videos. All right, friends, that is all from my side for today. Thank you so much for joining this session. I sincerely appreciate your time, attention, and active participation. I hope you found this webinar useful and that it adds value to your professional journey. Take care of yourselves and your loved ones. Stay curious, keep learning, keep growing, and never stop believing in yourself. Have a wonderful day, and I will see you in the next webinar. Thank you, everyone. Thank you.